the aspects looking at the neural substrates of valuation. Just talking and starting very broadly with the idea of an amotivational syndrome, which often comes up. We hear a lot anecdotally and in the media about this amotivational syndrome that might be associated with heavy cannabis use. And McLaughlin and West wrote this paper in 1968. It could have been written in 2017, but they were some scientists that pointed out, while systematic studies of the recent wave of marijuana users are not yet available, clinical observations indicate that regular marijuana use may contribute to the development of more passive, inward-turning, amotivational personality characteristics. So is there any truth to this? As I said, we hear it often anecdotally and a little bit in the science. In popular culture and in the media, we have lots of representations of this, lots of examples I could give. Seth Rogen movies are one, where you often see very heavy cannabis use linked to lower life achievements. And I always like to point out that Seth Rogen and his friends are actually very hardworking, producing lots of movies, making lots of money, but that's not how they're depicted in the movies. Is there any truth behind these caricatures? We also see changes in the media and in popular representations. We now see cannabis use sort of normalized more. We see women, older adults, affluent people using cannabis in different ways on a fairly regular basis. We also have celebrities, athletes, and others coming out. I like to give the example of Michael Phelps, who I think to this day remains one of, or the most decorated Olympian, very motivated in many ways, who's spoken about his love of cannabis. So the horizon, the landscape is actually not that clear on this link between amotivation and cannabis use. We've had large changes in Canada with Bill C-45 coming out in October 2018, which legalized the non-medical use of cannabis in adults. And these are statistics of use across Canada from 2022. And so roughly 27-ish% of Canadians report using cannabis in the past year. And the trend is slight increases over the past few years. But our concern is, as researchers and those working in healthcare, is that these fairly serious policy changes around cannabis could trigger a very broad range of effects and could result in changes in reduced goal-directed behaviors in youth and in the population in general. So there is a little bit of literature on this. It's not as clear as we would probably like, but I always like to present this study, which is a meta-analysis by Seelens and colleagues showing this relationship between daily cannabis use and adverse, basically functional outcomes. So your ability to finish high school, your ability to get a higher degree, and there's really this dose-dependent characteristics. These dose-dependent characteristics that you can see with the strongest effects always occurring in daily users. And because this was a large sample, they controlled for many factors like co-occurring substance use, family substance use, things like that. So while we have some good longitudinal data suggesting some changes and reductions in goal-directed behaviors, we have very little understanding of mechanisms that may be underlying these. My interests are always in motivation. And if we look at cannabis use disorder and cannabis use disorder criteria, I always like to point out that a large proportion of the criteria relate to changes in motivation. So things like spending a lot of time trying to obtain cannabis, use it, recover from it. At the same time, less motivation for things like work or social activities, cravings going up, not prioritizing other responsibilities in your life. So there's this clear change in valuation that occurs with cannabis use disorder. So many of us as researchers in the field of motivation and particularly with cannabis, it's becoming very clear to us the difficulties in conducting research in this area. One of the main ones being the heterogeneity of the users that are often sampled in studies. So researchers put together individuals who use on a daily basis and those who have maybe tried a few times in their lifetime. We also are all very aware of this escalation of THC over time, from 1 or 2% in the 60s and 70s, going up to almost 20% commonly reported now. The other thing we were just talking about before the session started is the heterogeneity of cannabis compounds, that we always talk about it as this drug, this one drug cannabis, when we are very aware now of this alphabet soup of cannabinoids, and you're not always sure what you're getting with every spoonful. And then also, are we even studying motivation? Some of the motivation tasks, it's not clear. They're kind of boring, or would anyone be motivated to do these tasks? So lots of limitations as we try and make a dent in these areas. I don't have to give a very big introduction to neuroeconomics. James and Michael have done a great job of this. So I'm not going to describe this too much, but just to say that that neuroeconomics really provides us with a great framework to understand the neural foundations of decision-making and really get a little bit more into the mechanistics of how we make decisions. Before I get into some of the demand work, I'm going to do a little sidebar just to talk about effort-based decision-making. So instead of looking at valuation of cannabis, what about valuation for other things, for work, for example? So I got interested in effort-based decision-making a while ago. And then as I did more and more work in this area, I became aware that almost all the decisions we make on a daily basis are effort-based decision-making. So things like, should I carry an umbrella today? It's heavy, it's annoying, but I also don't want to get soaked if it's pouring. We do this all the time, and we make judgments at work. Should I collaborate on this project? It could get me a Nobel Prize, or maybe it's just a lot of work that goes nowhere. And the point is that we often need to make choices when we don't have complete access to information. We don't actually know for sure if it's going to rain today. We don't know quite what the project is going to turn out. If you do a review, sometimes you open it up and it's 150 pages. There's so many things we don't know. We're constantly making these cost-benefit integrations in our brain to think in a very short context, is this worthwhile for me to do? So I really like this task called the effort, or the effort expenditure for rewards task. And this is a scanner-based version that's adapted from Errol Progesim and colleagues from 2018, and it really parses out choice behavior. So you can parse out a prospective phase where people see cues related to how much effort they're going to have to do, or it could be a reward cue, how much reward they could get for a certain trial. And then there's an integration phase where they receive the second piece of information. If they got effort first, then they'll have a reward cue, and then they make a choice after. So the task is very simple. It's a finger tapping task. You can choose an easy task or a hard task. The easy task has you pressing with your dominant index finger 30 button presses, which is, you can try it right now. It's very simple. It doesn't hurt. It doesn't take very long. It's easy. The second, or the harder version of the task, or the harder trial, is using your non-dominant pinky finger, making 100 button presses in 21 seconds, which becomes tiring very quickly. Again, it's not painful, it's not dangerous, but after you've done it 10 or 20 times, you really think whether that 375 is worth it. So I really like this task. As I said, it can be done in the scanner. We have people make the choice for the hard or the easy task in the scanner, but they actually do the work outside the scanner. So that once they're out, then they do all the finger tapping, which I think is also very representative of saying yes to things in life and then having to do the work after. So this is the sample that we had: 21 people in the CUD group, 20 healthy controls. And they had a QDIT score over 10, with about starting cannabis use at the age of just over 22. And most of the individuals reported dried flower as their preferred method of consumption. So these are the behavioral results from in the scanner, and they turned out very nicely, as you would expect when you're asked to put out more effort. As the effort levels increase, people's choice to do the work decreased, which makes sense. And then as the reward magnitude goes up, the choice to accept the reward, of course, goes up as well. So you can see the difference between CUD and HC groups. It's in the latter bars. You can see at high effort, so 80%, 100% effort, that you start to see the groups pulling apart a little bit. This was actually just a trend. It didn't quite reach statistical significance, but our hopes are with a bigger sample, it'll pull it apart more. And similarly with reward, we also see the groups pulling apart at the higher levels of reward. So let's look at some of the fMRI data. This is related to the very first exposure to the cue around effort, so prospective coding of effort. And this is from a whole brain analysis. The only area that showed up differently was the VMPFC, or the ventral medial prefrontal cortex, with less activity shown in the CUD group, which really is in line with the role of the VMPFC in forming reward-based predictions. When we lowered the threshold slightly in the reward condition, we see the same finding in overlapping areas of the VMPFC as well. We also see decreased activity if we go to the full threshold, in the temporal gyrus as well as the posterior cingulate during prospective reward coding. And these are actually overlapping in areas that have been previously outlined on cognitively effortful rewards in healthy individuals. So we're seeing less activity here in the CUD group. If we move on to the next phase, the integration, so when people now have the complete set of information to make their choice, we see that there's, in general, characterizations of increased activity across multiple areas, like also in temporal areas. You can see here I was a little bit more surprised at the back of the brain and in some thalamic areas as well. So these are also areas that have been previously shown on effort-based decision-making tasks as well. We ran a series of correlations with an ROI in the ventral striatum, which was from the Lopez-Gamundi meta-analysis from 2021. So we used those coordinates, and we actually saw only in the higher levels of effort and reward conditions these small but nonetheless significant correlations between greater activity in the ventral striatum and increased choices for the high effort trials or the high reward trials. So just to summarize very quickly, this is the first study of the neural substrates of effort-based decision-making in CUD, and the behavioral results were very nice and clean, and at the same time show this trend of accepting less trials in both the high reward as well as the high effort conditions. The group differences in neural activation during prospective reward valuation and during integration of effort highlight there are frontostriatal differences, but there's also posterior cortex processing alterations occurring. And the prospect phase ventral striatal ROIs demonstrate links with high effort and high reward choices. So overall, this work is really beginning to shed light on mechanisms in valuation signaling that might underlie maladaptive cost-benefit decision-making in CUD. So now moving from motivation for monetary rewards back to cannabis, what about altered motivation for cannabis itself? So I'm not going to go too much into the background on cannabis demand. We've had a great description of that to start off with, but just knowing that this is a critical measure of motivation and that we can use these very specific motivational indices to look at choice behavior. So we described before intensity as the consumption at a minimal price, elasticity, the person's sort of sensitivity to the changes in price, breakpoint where the price is simply too high, and we can characterize the curves as inelastic, elastic as behavior choices begin to change based on price, and then suppress demand. We've adapted this task now, the MPT, for the scanner, and basically asking people in the scanner, how much would you consume if it was $1 per gram? We have certain assumptions. It needs to be consumed over the typical week. It has to be from your preferred type of cannabis. You can only get it from one source. And yeah, we were very successfully able to apply this in the scanner. So this is the first 20 people that we ran through the scanner version of the MPT. And we had on the scan day, people provide a urine sample for comprehensive cannabinoid analysis, and basically had our colleague Phil Britz-McKibben and his lab do a mass spec analysis to specifically look at THC metabolite concentrations. So this way we don't have to take any specific self-report measures, but really look at a quantitative measure of cannabis use. So first of all, the behavioral results are very nice. From these first 20 people in the scanner, we can very clearly see a prototypic curve coming out with inelastic, elastic, and suppressed demand coming out. We can see the trichotomous choice types as well. And these behavioral findings in this small subsample in the scanner version are very similar to what we see in much larger CUD groups on the MPT. And so we're showing basically that cost-benefit choice behavior is successful in this fMRI version. So the scanner version here produced some very nice findings in, if we compare elastic versus inelastic conditions, you can see differences coming out in the bilateral caudate, bilateral insula as well, dorsal, lots of dorsal ACC coming out. And these are regions that have previously been outlined on demand decision-making tasks. And these include areas related to incentive salience, interoception, craving, and conflict monitoring. What's interesting is that these pilot data depict differential recruitment during these different motivational indices, during these different motivational phases, with the largest recruitment always occurring during the elastic phase. So these are very nice pilot data to start from. We were also interested in seeing whether behavioral performance related to a person's urine screens and the mass spec results. So we were actually able to detect both major and minor THC metabolites. There were quite a few. The one that showed that probably the nicest profile was THC glucuronide. And we found that it positively correlates with intensity and Omax in a positive fashion, and elasticity negatively. So again, the more THC glucuronide in someone's urine, basically the more they are willing to consume at a minimal price, and the more they're willing to spend, so the greater their Omax as well. And again, this inverse relationship with elasticity consistent also with the idea that the slope of their curve in those that are heavier users they're less affected by price. So these pilot data suggest that individuals with higher THC glucuronide metabolites are less sensitive to cannabis price changes. They spend more money on cannabis and show higher levels of unconstrained consumption. We then took an ROI of the caudate and looked at whether there were relationships with THC glucuronide. And in fact, there was with higher THC glucuronide with both bilaterally, the left and the right caudate, during, again, just the elastic demand phase, not during suppressed or inelastic phases of the task. So again, since these findings are still preliminary, we can interpret with caution, but they nevertheless suggest this great potential relationship between THC metabolites and behavioral economic demand and neural measures as well of the MPT. So the key findings here are that we can use cannabinoid urine analysis to show assay validation, specifically looking at very targeted THC metabolites. We find relationships with behavioral economic demand measures, as well as with brain activity during very specific motivational phases of the MPT task. And this is the first study to link very specific THC metabolites with very unique motivational indices of choice behavior. So we know that motivation is a very multifaceted construct. I've done other studies looking at reward learning. Here we're starting to look at valuation, at anticipation, costs, and effort. And all of these things can be very differentially affected by heavy chronic cannabis use. We also need different frameworks to capture decision-making, which is such a complicated process, and neuroeconomics really gives us a neural foundation with which to better understand this. We also need novel methodologies for targeting the multiplicity of cannabis, and I think some of the urine data that we've presented really gets at some of the multiplicity of cannabinoid actions as well. So to end there, thank you very much to my colleagues and collaborators, James McKillop, Phil Brits-McKibben, Michael, all of my lab members and staff and students. Thank you very much as well for your attention.